Before viewing video lessons, it is important to read the textbook using the learning guide as your turn-by-turn directions. Then use the learning guide to take organized notes in your own words with examples and pictures. This video is a continuation of Human Memory, Chapter 7. So far, we've gone through this model of memory, and we've talked about the importance of paying attention and then working with and encoding well our experiences in order to move our memories into long-term storage with the goal of retrieval, which is hopefully accurate, complete, and at the time I want to remember it. So we're going to look at some problems that can occur in this process. So if I'm not able to fully and accurately retrieve, we oftentimes call that forgetting. So retrieval problems include incomplete retrieval. This would be where I get part of the memory, but not quite everything I needed. We feel like it's right there on the tip of our tongue. And so sometimes if you're having a tip of the tongue problem, you'll try to access other retrieval cues to help you. So you may try to think of everything else you can think of and hopefully activate the semantic network that will get you to the right answer. Sometimes that works, sometimes it doesn't. Another retrieval problem is where we get the right answer. We retrieve an accurate memory, I should say, but we can't remember exactly what our source of information was. So I think I know where I got this idea, but I'm totally wrong. Now, this is important, especially in your college classes, because sometimes that source of information that you've retrieved a memory from is not a good one. So let's say you're taking your psychology test and you pull out what you think is a good, accurate answer to one of the questions, because you're sure you heard me say this thing in one of the videos. But what if that was something that you read in Twitter, or you saw in a video that was posted in your Facebook feed? Twitter and Facebook may not be the most accurate sources of information, so you may put down an inaccurate answer because of the source monitoring problem. One of the biggest problems with retrieval is that they can become inaccurate due to reconstruction. So every time you retrieve a memory and you pull it out, you're pulling it out of an overall schema and semantic network. And so you're going to pull out bits and pieces attached to that schema that don't actually belong. And we can actually make this inaccurate reconstruction worse with something called the misinformation effect. So let's say you come to campus to take your test for the midterm, and while on campus you witness a fender bender, a little car accident. And about a week later, you're called in to tell what you remember. You're called in to testify about what you saw the day of the accident. And so you're asked a question. Makes sense. How fast were the cars going when they hit each other? And you answer it. Did, 20, 30, 40, 50, whatever. And then you're asked a follow-up question. Did you see any broken glass? Now, the true, accurate answer would be no. But 14% of you will say yes. And when you say yes, you will 100% believe it. Because when you went into your memory and pulled out glass related to this accident, you're going to have that memory attached to memories in which auto glass was intact and memories in which auto glass was broken. And the broken auto glass is also tied to the car accidents. And so what you're going to do is you're going to pull out an inaccurate memory. That's 14% of you. Now with the misinformation effect, I can actually increase the inaccuracy of your memory. So if my first question primed you with the word smashed, how fast were the cars going when they smashed into each other, I'm going to prime your memory. I'm going to activate memories associated with the word smashed. Then when I ask if there's broken glass, because smashed was previously activated, it's going to increase the likelihood that the memory you retrieve is going to be inaccurate. Now, another thing that has a big impact on forgetting is meaning. So to look at this, we want to look at a classic experiment in psychology. So there was a researcher named Ebbinghaus, and what he did was he took a group of people and he sat down and he gave them a list of things to remember, and they practiced and practiced and practiced and practiced and practiced that list until each person can get it 100% right. Then he tested them periodically over time to see how much of that list they were able to remember. That's their retention level. So this research turned out to be pretty depressing. So at one point in time, I know everything I need to know for the test, and within 20 minutes, I would be failing. I would get a 60%. Within an hour, I'm definitely failing, and it only goes down from there. Whew, man, how does anybody ever pass a class then? Well, the thing you have to know about Ebbinghaus is when he did his research and when he had them remember 100%, what he was actually having them remember were nonsense syllables, just random strings of vowels and consonants crammed together, kind of like the one we used in the previous videos, ZRTGAB. Cool. Those symbols have absolutely no meaning. And when something has no meaning, you cannot deeply process and encode it, which means that you don't have long-term retention. So if you're watching this video and just recognizing that, yeah, this makes kind of sense, but you're not writing it down in your own notes, in your own words, you're not creating examples, you're not making pictures, your long-term retention is going to be poor. So the reasons why we forget start with ineffective encoding and not doing encoding specificity. If you have not done a good job of learning this material and creating those deep, richly encoded memories, then no retrieval cues are going to help you find it on test day. Now, some memories are lost due to decay or disuse. So memories are stored biologically, and we know from chapter 3, the biological bases of behavior, that if a particular neural pathway isn't exercised or activated, it tends to shrivel and atrophy and get pruned, making it harder to find those memories. So if you look at how the brain works, memory could be lost, it could be difficult to retrieve if we haven't activated or used it. Now at this point, the research supports that decay and disuse happens for sensory and short-term memory most. Long-term memory, it tends to make it just a little less able to be retrieved, but it isn't lost altogether. Another reason why we forget is due to something called interference, and we have another slide that's going to detail both retro and proactive interference. So interference is where you either have retroactive interference, where learning something new interferes with something you already knew, or old learning interferes with your ability to learn something new. So the effects of interference are most pronounced the more similar those two materials are. So this particular example here, psychology and economics have a little bit to do with each other, so there'd be some interference. But if these were sociology and psychology, which are much more closely related fields, there would be more interference. So what happens with interference is you have distractions that reduce the connections in the semantic network, or you have inappropriate creations of connections, meaningless, unhelpful, inaccurate connections, or you can even have no connections at all. So if you don't build the right kind of connections, you cannot have retrieval. Now, the final theoretical reason about why we forget is something called motivated forgetting or repression. And this one is controversial. This one says that I can make myself forget. That I can say, no, 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 I don't want to think about it, 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 and then I can make the memory go away. Most of what we know about how the brain and memory works suggests that this is probably not a very common occurrence. In fact, the more we try to not think about something, the more we try to forget something, oftentimes the more we think about it and the more we remember it. This is what happens for people who have PTSD. People who have PTSD have experienced a traumatic, upsetting, I don't really want to think about this anymore kind of event. Yet what happens with that particular disorder is it keeps popping into their head when they don't want it there. It's a very intrusive, unwanted memory. It's coming in, it's making me feel upset and uncomfortable, and I don't want to think about it, yet I can't stop. So there are some people, however, to include Freud, who believed that really traumatic events, particularly in childhood, could be repressed. They could be driven into the unconscious. There's a lot of controversy about this, about whether or not so-called recovered memories from childhood are true, accurate memories, or whether they are created memories or very manipulated memories through the techniques that people try to use to recover those. So there's a lot of controversy with that. What I will simply say is when it comes to this class, please don't try to forget this information before test day. You want to do the opposite of that. So our model of memory now is complete. We have looked at how sensory information comes in, enters sensory memory, we pay attention to it, it moves to short term, we do some hard work in working memory to encode it well, which creates a memory code that's stored in long-term memory and that hopefully you will retrieve on test day.